In this video, we want to take a look at linear inequalities, and we're going to stick to one variable. So hopefully the symbols that you see here are familiar to you. You have that little arrow type thing that points to the left, and sometimes it points to the right. Sometimes it has a line under it, and sometimes it doesn't. Okay, so what do each of these mean? Let's see if we agree. The ones that point to the left mean less than. If I have it pointing to the left and I add a line underneath, it means less than or equal to. All right, now if we flip it and it points to the right side, then that's going to be greater than. If I can spell, there we go, greater than. And again, if it has the line, it means greater than or equal to. All right. So pointing to the left, less, and pointing to the right, greater. So L's left and less, and greater, it's got the R, goes to the right. So how do I graph these? Well, we're sticking with graphing on just a number line because we're only using one variable. So I'm not going to be real fancy with my graphs here. I'm going to have a number line. I'm going to find where 3 is because that's the boundary for our inequality here. And I want all the values that are less than. Well, if it's less than, it's something like 2 or 1. It's going to the left. So I'm going to shade this way on the left. Right? And I put a little arrow there to indicate it goes as far as I want it to go. Now I could include 2.9, 2.999, 2.9999999 as many times as I want, but I can't include 3. So to show that 3 is our boundary point but not included in my solution set, I would use an open unfilled circle. All right, that's probably the notation you're familiar with. We will talk about a slightly different version of notation in just a moment. All right, so the next one says x is greater than or equal to 2. So again, I'm going to have my number line. I'm going to figure out where 2 is. Just put a 2 there. And then I want greater than. So those would be the numbers to the right, like 3, 4, etc. So this time I'm going to shade to the right. We'll also put an arrow on there to indicate it's going to continue to the right. But the difference with this one, besides being greater than, is that it also can include the number 2 because 2 is equal to 2. So when I put my circle there, I'm actually going to fill it in and make it a solid circle. All right, now this last one is a little bit tricky. Go ahead and pause just a moment and see if you can come up with what the number line graph would look like. All right, I'm going to go ahead. Oops, that's not what I wanted to do. There we go. Let's take a look at this one. All right, so I'm going to put my number line down here. I'm going to put my 4. I know something on this side would be 3, something on this side would be 5, correct? Okay, now wherever I shade, whatever numbers are on that shading part should work in my inequality. Let's look back at this one right before. So 3 was on the shaded part here, and if I put 3 is greater than or equal to 2 would be a correct statement. It would be an accurate, true statement. So if I see 4 is greater than or equal to x, and I would shade over there by the 5 because it's greater than, right? Is 4 greater than or equal to 5? Well, no, it's not. So 5 shouldn't be on the shaded side. In fact, the 3 needs to be on the shaded side because 4 is greater than or equal to 3. It is got the or equal, so we're going to put a filled circle there on 4. Now you might be wondering, okay, so why, if it's greater than, is it not going to the right? Well, the key is if you notice that both of these first two had an x to start with. This one, the x is second. So if I rewrite this, if I'm going to come around down here, if 4 is greater than or equal to x, that would be equivalent to saying x is actually less than or equal to 4, right? So 4 is greater than x, so x is less than 4. So the rule is if you're going to graph an inequality, you probably want to go ahead and rewrite it, if it's not already in that form, rewrite it so that x is on the left-hand side. Then your rules of less than goes to the left, greater than goes to the right will work. Okay, so now I want to show you an alternate form of graphing, a different notation than you might be used to. If I have x is greater than a, I would shade to the right, But another way, instead of using an open circle to show that the endpoint is not included, would be to use a parenthesis. Now we start to use this notation on our graphing when we want to give our answers in what we call interval notation. And the reason is then I've got consistent notation between the graph and my interval. So you notice that I'm starting here at A and then I'm shading to infinity, and when I come down here and I write my interval, it starts at the A, ends at infinity, and I'm using a parenthesis on both of those to show, well, they're not really included, right? Infinity is always going to have a parenthesis because I can never get there. If I want instead x to be greater than or equal to A, well, the graph is very similar, starts at A, goes to infinity, but this time you notice I use a bracket, all right? So open parentheses are equal to open circles, and a bracket is equal to a filled in circle. All right, we've got the same thing with the less than. So let me pull this down here. And if I have x is less than A, then I have, again, in negative infinity going to the A. So notice the order it follows on the interval. It follows the order of the number line. The shading part starts at the negative infinity, goes up to the A, does not include it. So we use that parenthesis. On the x is less than or equal to A, well, it's shaded here on this left side, starting from negative infinity up to the A, but this time it's or equals to, so we use that bracket, right? So my interval down here matches my number line. Just remember, you always use that parenthesis on infinities. All right, let's try a couple practice problems. So what if I give you a graph? Could you turn that into an inequality statement or an interval statement? So in this one, I'm going to look at where is it shaded. It's shaded from the -5 to the -2, right? So interval-wise, negative infinity to -2, and I match my notation and use a parenthesis. What is that as far as an inequality? Well, it's everything to the left of the -2, so it's x is less than -2. Okay, and I know it's strictly less than because that's the open parenthesis. The next one, it also starts at negative infinity, goes to 1 this time, but you notice it's a bracket. So when I go ahead and I put my interval, always a parenthesis with infinities, up to the 1, I'm going to use a bracket. And it's to the left, so it's still going to be x is less than, but this time we're going to add the or equal to the line underneath to show that it includes the endpoint. All right, let me pull up a couple others here and see if you can do these next few. So go ahead and pause it just a moment and see if you can do those. All right, I'm going to come back in here and see if we match our answers. So this time it kind of got cut off, but it's going from 5 to infinity, right? So I would use the bracket just like on the graph and go up to positive infinity, close that. This time, because I'm going to the right of the 5, I'm going to see x is greater than, and it's greater than or equal to, again, because it shows the bracket, x is greater than or equal to 5 would be my inequality answer. Excuse me, for number 10 here, it's pointing towards the negative infinity up to the -5. So I'd start negative infinity to my -5. Always parentheses on infinities. Look at my graph. It's got a bracket on the 5, so I'll use a bracket on my interval. What does that mean as far as an inequality? Well, it's going to the left, so we're going to be using an x is less than, and I know I use the or equal because of the bracket, -5. Last one here, let's try number 11. Well, in this one, it's starting at the -2 going to positive infinity, so my interval, -2 to positive infinity, and that looks like a parenthesis to me, so I'm going to call it a parenthesis and a parenthesis on infinities. So this time, because we're going to the right, we would say x is greater than, no line under it because it's a parenthesis, endpoint not included. Oops, not infinity, sorry about that. X is greater than a -2. Let's flip it. Right? What about if I give you a statement? Could you translate that into an inequality statement? So if x is at least 3, so if it's at least, that means it could be 3, or more. So x would be at least or more than 3 would be x is greater than or equal to 3. Pause it a minute and see if you can do those next few. Okay, let's take a look. If I have x is no more than 5, so 5 is the most I could be, so I'm thinking on my number line here, here's 5. I could be 5, and I can use my circle or I can use my bracket. Either way, I can be 5, but I'm no more, so I'm going to be to the left. So my inequality would be x is less than or equal to 5. Okay, and I forgot to graph that first one. That one would be x is at least 3. So filled circle or the bracket, and at least, so it would be going to the right. All right, now if it's in between, let me look at that graph. So here's 1 and here's 4. I want to be in between. I don't want to be either 1 or 4. I want to be in between it. So I don't want to include, I'm going to use parentheses or those open circles. So that's what the graph would look like. What would an inequality look like? Well, my x, my solutions are trapped between two numbers. It's less than the 4, right? X is less than the 4, but it's greater than the 1. So I can say 1 is less than x is less than 4 and write it as one single string inequality. Right? Let me do the next two quickly. X is no less than 6. All right, no less than 6. So 6 is the smallest it can be. That means it actually needs to be bigger than or equal to the 6. So x would be greater than or equal to 6. And my last one here, if x is at most 2, well, here's my 2. I could be 2, right? So I can use a circle filled in if I want, but at most means I can't be any more. I have to be less than, so we'd say x is less than or equal to 2.